Good day! This is Ma'am Aiko Piconas, your grade 8 science teacher. For today's lesson, we're going to determine the number of protons, neutrons, and electrons in a particular atom. Let us have a recap about your previous lesson about atoms. Arrange the jumbled letters to form a word. Use your knowledge from the previous year by answering the question adjacent to the jumbled letters. You have 5 seconds for each item. Number 1.
Time's up. Let us answer the first question. What is the smallest part of matter? The answer is atom. Have you got it right? Let's proceed to the second question. Number 2. Let's check whether your answer is correct. What do you call the positively charged particle of an atom? The answer is proton. Have you got it right? Let us proceed to the next question. Number 3. Let us answer the question. What do you call the particle of an atom that is electrically neutral? The answer is neutron. Let us proceed to the last question. Number 4. Let us answer the last question. What do you call the negatively charged particle of an atom? The answer to the last question is electron. Give yourself a round of applause for doing the activity so well. After answering the activity, let us have a short recap about it.
Number 1 is atom. Atom is the smallest part of matter. It is also the smallest unit of matter that has the characteristics and properties of a chemical element. Next one is proton. Protons are the positively charged subatomic particles of atom. These subatomic particles are found inside the nucleus of the atom and is also the heaviest among the 3 subatomic particles. The third one is neutron. Neutrons are the neutrally charged particles of an atom. They aren't positive like protons, nor negative like electrons, but they have huge importance on how the atoms acts and behaves. The last one is the electron. The electron is the negatively charged subatomic particle of an atom. This subatomic particle is the one that orbits the nucleus.
Now that you are very familiar with atoms and its subatomic particles, let us have another activity. Using the atomic model of Niels Bohr, make an atomic model of the following given elements. An example of Niels Bohr atomic model is located at the right side of this video. The given atomic model is the atomic model of carbon with mass number 12, 6 electrons, 6 protons, and 6 neutrons. You have 3 minutes to answer this activity. Time's up. Let us check whether your works are correct. Is your answer similar to the one illustrated at the left side of this video? If yes, then you are correct. Protons and neutrons are located inside the nucleus of an atom, and the electron is the one who is revolving around the nucleus. Do you think this one is correct? Yes, it is. Very good. Let's proceed to the next one. Do you think the illustration is correct? If yes, then you are right.
In the activity, there are 4 ideas being portrayed. Number 1, protons and neutrons is located inside the nucleus of the atom. Number 2, protons and neutrons comprises the mass number of the atom. Number 3, electrons revolve around the nucleus. And number 4, in a neutral atom, the number of protons is always equal to the number of electrons.
To clearly understand the number of protons, neutrons, and electrons in an atom, let us discuss the following terms. Protons. Protons are the positively charged subatomic particles of an atom. One or more protons are present in the nucleus of every atom. They are a necessary part of the nucleus. The number of protons in the nucleus is the defining property of an element. It is referred to as the atomic number. Therefore, the number of protons is equal to the atomic number of the element. The neutron is a subatomic particle which has a neutral charge, and the mass is slightly greater than that of a proton. Protons and neutrons constitute the nuclei of atom. Since protons and neutrons behave similarly within the nucleus, and each has a mass approximately 1 atomic mass unit, they are both referred to as the nucleons. Therefore, the total number of protons plus the total number of neutrons is equal to the atomic mass of the element. The electrons are the negatively charged particle of an atom. Together, all of the electrons of an atom create a negative charge that balances the positive charge of the proton in the atomic nucleus. Therefore, in a neutral atom, the number of protons is always equal to the number of electrons. Not all atoms are neutral. An ion is a charged atom or molecule. It is charged because the number of electrons do not equal the number of protons in the atom or molecule. An atom can acquire a positive charge or a negative charge depending on whether the number of electrons in the atom is greater or less than the number of protons in the atom. Therefore, to get the charge of an atom, you must subtract the number of protons to the number of electrons. Again, atomic number is equal to the number of protons. Atomic mass is equal to the mathematical sum of the number of protons and the number of neutrons. Therefore, to get the number of neutrons, you must subtract the number of protons to the atomic mass. In a neutral atom, the number of electrons is always equal to the number of protons. But not all atoms are neutral. Ions are charged atoms. To get the charge of an atom, you must subtract the number of protons to the number of electrons.
Let us have sodium for example. This is the nuclide symbol of sodium. A nuclide symbol showcased the basic information of an atom, like the symbol, the atomic number, the atomic mass and the charge. As seen from the nuclide symbol, the atomic number of sodium is 11. And as mentioned earlier, the atomic number is equal to the number of protons. Therefore the sodium atoms have 11 protons. In a neutral atom, the number of protons is equal to the number of electrons. And since it is clearly seen from the nuclide symbol that the given element is a neutral atom, the number of electrons in sodium is 11. The mass number, also known as the atomic mass number or nucleon number, is the total number of protons and neutrons in an atomic nucleus. From the given nuclide symbol, the mass number of sodium is 23. By subtracting the number of protons, which is 11, to the mass number, we can infer that the number of neutrons in sodium is 12. The charge of the given sodium atom is 0, since the mathematical difference between the number of protons and neutrons is 0. This time let us consider sodium ion. Since the number of protons is the defining property of an atom, the number of protons in a sodium ion is 11, which is equal to its atomic number. As seen from the nuclide symbol, the charge of the sodium ion is positive 1. And since the charge is positive 1, it means that there is one more proton than the number of electrons. So 11 protons less than 1 is equal to 10 electrons. Since the number of electrons do not affect the mass number of an element, the number of neutrons remains 12.
Now that you have learned how to determine the number of protons, neutrons, and electrons in an atom, let us now have a short activity. I am giving you 5 minutes to answer the activity. Time's up. Let us now check whether your answers are correct. Check your own work by referring to the table. Have you got it right? Very good. Now, to summarize our lesson, let us answer the next quiz. On a sheet of paper, write true if the statement is correct and false if not. Number 1. Atomic number is equal to the number of protons. Number 2. In a neutral atom, the number of protons is always equal to the number of electrons. Number 3. The number of neutrons is equal to the difference of the mass number and the number of protons. Number 4. In an electrically charged atom, the number of protons and neutrons are equal. Number 5. The charge of an electrically charged atom is determined by the number of electrons. Let us see if you got it right. Number 1, true. Number 2, true. Number 3, true. Number 4, false. Number 5, false. That's all for today's lesson. I hope you learned something today. This is Ma'am Aiko Picones, your grade 8 science teacher, signing off.